Hello, thank you for watching this video. In this video, I'm going to be explaining variations, particularly the inverse variation. By inverse variation, we mean that there is a relationship whereby something is increasing as another thing is decreasing. So let's take a look at the examples that we have provided. If you lose $10 every hour, that means that your amount of money is decreasing as the time is increasing. So as your money goes down, the time goes up because time is increasing and your money is decreasing. Let's take the second example. If you shrink 10 centimeters shorter every 2 minutes, that means that your height is going down as time is going up because time is increasing as your height is getting down or it's decreasing. So that's another inverse variation. Then let's take a look at the last example that we have. We have 3 people die every 5 days. That means the population is decreasing as the number of days is increasing. That's another inverse variation right there. So the way that this would be denoted is that to say y is directly proportional to 1 over x. So when you put 1 over x, so in the direct relationship where y is directly proportional to x, which is just y alpha x. In that case, both were increasing. However, when y is decreasing as x is increasing, we denote it as this. So like we put x under 1 so that y gets to actually decrease. And this can also be denoted by y is equal to k over x. So for our exercise, we are going to be seeing how these examples are going to come out, whether that relationship is going to be direct or inverse. Let's take a look at A. The number of sweets you buy in relationship to the money in your purse. Or since the more sweets that you buy is less money in your account, so sweets is going up, money is going down. That's an inverse relationship as described earlier. Let's take a look at B, the length of stretched rubber band with the force applied. With the force applied. So in order for the rubber band to grow longer, you have to apply more force. So it's more length or longer stretch and it's more force. Since both are increasing, so as the rubber band is increasing, so is the force. That is a direct relationship. So this is not an inverse relationship. Let's go to C. The thickness of tires on a car in relation to the time if the vehicles are always moving. So we know that as the vehicle is moving, that the car tires get to decrease their thickness, so they are wearing out. So because the thickness is decreasing as there's more time on the car being driven, that means that this is an inverse relationship because it's less thickness, more time. Let's go to D. The number of years left in your life in relationship to your age, or as your age increases, the number of years left for you is decreasing. So this is an inverse relationship. Then the height of a newly planted gum tree in relationship to its age, or as this gum tree grows older, it also grows taller. So height is increasing with age, and this is a direct relation. It's not inverse. Here we're given this example whereby y is inversely proportional to x minus 2. And then we're given that when y is 8, x is 10. So we start with our relationship here, like we start with what we have. So y is inversely proportional to x over 2. So we have to write y is like y alpha 1 over x minus 2. Since it's inversely proportional, so we put 1 over x minus 2. And that can also be written as y is equal to k then over x minus 2. So now to find our k, we get to use the values that we're given. So when y is 8, x is 10, so we put 8 and we put 10 here for x. So now we get to calculate for our k, and we actually see that our k is 64 after working out this line. So our relationship that we derive from this question that we are given is that y is equal to 64 over x minus 2. This is the inverse relationship that is between y and x. Now here we're told to make separate graphs of y in relation to x. showing these following relationships. So here in the first example, we are familiar with y is directly proportional to x. That means that y increases as x increases. So here, as x increases, so does y increase. So this would be smaller, and this would be bigger, and this would be bigger, this would be bigger, and then the biggest is found here at the edge. So it's the y. So the biggest x gives the biggest y, smallest x gives a smaller y. So this is the relationship that we find. You can also draw this graph by actually putting in numbers. So when you put y is equal to kx and you put numbers, so if you put 1, 2, 3, 4x, then you get to find the y's that you'll be getting. So just be familiar with this graph, because this is something that you have to be able to understand, or like just to allude to in the future, sort of memorize. Now let's move on to our second question. So this is y is inversely proportional to x, and this is the graph that is found from plotting this. So how would you come to this conclusion? Well, usually with these graphs, I'll just say you have to be familiar with them through memorizing them or something like that. And then y is directly proportional to the square of x, actually gives you this graph. So from plotting these questions in earlier questions, or from dealing with other questions that where you get to deal with graphs, that's how you get to be familiar with these graphs, and you just get stuck with this because it's only 3 of them for now. So it's easy to remember that, well, a direct relationship actually looks like this, an inverse relationship looks like this, and then a square relationship looks like this. So I'll just try explain more in the inverse relationship. So as x is increasing, y is decreasing. So this is a small x, it's giving you the highest y. This is a bigger x, it's giving you a less y. Then this is the bigger x, less y. So you can see how as x is increasing, we're getting smaller and smaller y. So this is why this graph is like this.